We are back with another build video. Today we will be building a variant of KebabFPV's Baby Tooth FPV drone. It's an ultralight FPV quad which typically runs on 1 to 2S batteries. It's small, light, and very quiet when it flies. Most importantly, it offers a roller coaster flight experience. So let's get started. We will be using 4 RC InPower GTS version 2 1202.5 6000 kV motors. An XM Plus receiver by FR Sky, or Free Sky. An Eachine Nano VTX version 1 without the microphone. Some Gemfan 3018 propellers. A Runcam Nano 2 FPV camera, a carbon fiber frame complete with TPU mounting pieces, a Play F4 flight controller complete with electrolytic capacitor and power leads. So before we get down to the nitty-gritty of the electronics, let's prepare the frame and get it ready to mount the other components. Here I am cutting out pieces of heat-shrink tubing to act as sleeves for the motor wires. They're 2 centimeters long a piece. We're going to slide them on the frame here. Next we'll be taking the motor wires and weaving them underneath the heat shrink tubing and mounting them with screws. If you have it, I recommend using Loctite for your screws. And here we are. Next I'll be taking my heat gun and shrinking the tube down over the wires. Make sure that the wires aren't crossed underneath the heat shrink tubing. And the finished product should be nice and neat. For the mounting screws, I'm going to be doing something different. Here I'm cutting up pieces of heat shrink tubing about 1/2 centimeter long and placing them over the mounting screws. These are M2 mounting screws, and I want to make them a little thicker because the rubber grommets are actually for M3 screws. This will help keep a tighter fit. We're going to prepare the flight controller with a little pre-tinning of the solder pads. This will make our lives easier when mounting the external modules. First things first, add some flux. Then we'll add a blob of solder to each solder pad. Flip it over and do the same thing to the motor mounting pads. We are going to wire up the receiver, but before doing that, we will bind it to our transmitter. Here I'm adding power from a bench power supply at 5 volts.
No winds of winter would blow.
We will wire up the receiver as follows. Here we have ground and 5 volts. I pre-tinned the wires and will solder them directly to the flight controller. We will be using UART1 with the TRAMP protocol. Before getting started, we need to remove the extra power leads from the Eachine Nano VTX. Pre-tin the wires. Connect the ground, power, the UART and the video out. Wiring up the camera is straightforward. But before we get started, the leads from the FPV camera are too short. Here I'm soldering some extension wires and adding some color-coded heat shrink tubing to the exposed solder joints. Here's the 5 volts and the video in. Since the PCBs of the flight controller and the external modules are exposed, we need to insulate them from each other to prevent short circuits. Here I am wrapping the external modules in some heat shrink tubing. Here I'm starting with the receiver and cutting away a little bit of the heat shrink so to expose the binding button and the LEDs, status LEDs. Next we will be adding heat shrink tubing to the VTX. I had a little trouble getting it over the button at the end of the VTX. Therefore I took it off and cut off a little slot for it to slide down over the button. Okay, we can start soldering the power leads to the flight controller. This is important. Pay attention to the standard color conventions. Red is for positive and black is for negative. You get that wrong and you will fry your board. For the capacitor, we will be doing something different. We are adding extension leads because the room inside of the canopy is so little. We will have to mount the electrolytic capacitor outside of the canopy on one of the arms. So just a note, electrolytic capacitors are polarized components. This means you need to connect the correct polarity. The polarity of the electrolytic capacitors is usually marked on the side of the capacitor. And before soldering them together, make sure to slide some heat shrink tubing over one of the wires. If you forget that, you'll have to desolder the connection and then resolder it again. And here's the finished product. Okay, now we're going to wire up the motors, but before we do that, we will add some double-sided foam tape and secure the receiver to the top of the flight controller. This is an important step. In this build, the top of the flight controller has a small arrow pointing forward. Remember this orientation and in which direction the arrow is pointing when mounting the flight controller to the frame. The arrow points in the forward direction. Here we're adding the rubber grommets. After securing the receiver and adding the rubber grommets, we are going to place the flight controller upside down in the frame. Make sure the arrow is pointing forward. We are doing this for the following reasons. The USB port of this flight controller is on the bottom, and the frame is not designed for a USB port of this type. This means that our motor configuration and other parameters will need to be fixed. That's not a problem. We will correct it later in beta flight. Here I'm trimming down the motor wires to the correct length. Stripping off the silicone insulation. Adding some flux and pre-tinning the wires, and then soldering each wire directly to the flight controller. You'll notice that the frame is sliding back and forth on my workspace. I later solved this issue by taking a blob of blue tack and using that to anchor the frame down to the table, as you'll see in a second. If you haven't noticed by now, I'm a big fan of blue tack. And here we are connecting the last two wires, and you'll see the frame is staying quite still on the table. Next, we will be adjusting the receiver antennas of the XM Plus receiver. And in this way, I am weaving them through the frame so that each antenna points to an arm directly opposite the other one. When they are pointing in the right direction, here I'm taking a zip tie, wrapping it around the arm, and weaving the antenna underneath the zip tie. I'll be doing the same thing to the other side. Next, I'll be taking heat shrink I am putting the heat shrink over the antenna and the zip tie, adding a little heat to shrink the tubing down, and cutting off the excess zip ties. This will hold the antennas nice and secure. And since we have zip ties on the table, let's secure our capacitor down to one arm of the drone frame. So let's assemble the canopy. With the double-sided tape we used with the receiver, we'll attach the VTX to the top of the flight controller. What was formerly the bottom now is the top. And you want to have the button right next to the USB port. Here I am screwing on the bottom mount of the canopy over the electronics. And you'll see here I made a mistake. I forgot to pull the wires of the FPV camera through the bottom piece. That's why I had to unscrew it, pull the wires through, and reattach it. The bolts that go over the bottom mounting piece. Here I'm adding them. This will add some extra weight and they aren't necessary. And the final piece, we will mount the FPV camera and use a zip tie to fasten the VTX antenna next to the camera. Let's cut off the excess. Pull it tight first. Looking good. We're almost done. Let's just add some finishing touches. Here I have some foam rubber. I am forming it by pressing it down to get a template and cutting them out with scissors. Here I'm forming it around the screws with my fingernails, using that as a template and cutting it down smaller. I'll be mounting this piece of foam rubber with my favorite glue, B7000. It is a surprise adhesive force. This was a great adhesive. Best-selling Europe and America. Mad fans around the world. Too bad it was a great adhesive. I still think it's pretty good. Add a little B7000 to the bottom of the frame. Wait a minute or two for it to get tacky and stick it on. Now we will be covering the pH 2.0 connector with a little heat shrink. And now comes the moment of truth. Let's get a battery and connect it. Don't see any smoke. It beeps a couple times and the LEDs flash. That's a good sign. So checking the overall weight without the battery, 47.5. One S battery, 60.6 grams. And a 2S, 64 grams. I forgot to remove the camera cap, so I'll do that now. 63.9. And as the last touch, to keep the battery secure, we will be adding a rubber band. And there we have it. This is an easy and fun build. The performance of this little drone is amazing and has become over time one of my favorites to fly. It is also a good starting point for people interested in building more complex drones. This is the first part of a series of articles and videos about this build. In the next installment, we will configure our baby tooth in beta flight, take it out to the field, tune it, and do some test flights. Make sure to stick around. Thank you for watching my video. Make sure to like and subscribe, and we will see you next time.